Tigris is an S3 compatible storage solution that makes it super easy to use within your Next.js applications for storing and retrieving unstructured data. In this video, I'm going to show you how a Tigris bucket can be used to store images that are generated from Stability AI and how those images can be referenced from within the application for easy retrieval and sharing. I'm also going to show you how you can deploy this demo repository to your own Fly account as it's completely open source. Let's take a look at the application and first understand how it works. So on screen is the application that we're going to be deploying today. As you can see, there are a number of images that are already here inside of this application for demo purposes. If I hover over one of these, you could see here is the prompt that was used to generate this image, as well as a button to download the image and copy it to your clipboard in case you want to share it in the future. I can come up into this prompt field and I can type in something that I want Stability to generate. So I could say a desert planet. I could change the width and height of the image if needed, but I'm just going to go ahead and click Submit. And then you can see in the bottom right-hand corner, there is a new square that shows up inside of my grid. The icon in the center is going to dynamically change depending on what part of the image generation process it's actually done with. Then once the image is finished being generated, it will appear automatically. This is all done asynchronously using a background job that monitors a database for incoming jobs to process with Stability, as well as to take those images and upload them into the Tigris storage bucket. Now let's get a little bit of a deeper look to understand behind the scenes how this application works. So this is the architecture diagram of all of the components that are required to make this possible. It's worth noting that the vast majority of these components actually run inside of a single fly.io account. So the vast majority of the logic is actually stored inside of a Next.js application, which includes the front end, some server-side actions, and then some API routes that are used for processing images. The next component we have up is a Postgres database, which is used to store the entries for each image that is generated, as well as the jobs as they come in from Next.js. There's also this background process here, which will pull every 30 seconds to Next.js to check for new jobs and process them when they're available. And then finally, inside of Fly, we have our Tigris storage bucket, which holds the actual image data that can be used to display the images within Next, as well as copy pre-signed URLs for sharing or downloading to your computer. And then finally, we have the Stability API, which we will use to send our prompts and image dimensions to generate an image. Now let's take a look at what happens when an image is requested, when the prompt is filled out and the image is requested. The first thing that happens when the user submits the form into Next.js is the record is stored inside of a database as a pending job. This includes the prompt, the dimensions, the time it was created, as well as the status of pending, so this way it knows that an image for that job does not exist yet, but it needs to be created. Next up, Next actually has a special component that will pull the Postgres database for updates to the job, provided they are in a pending or in progress state. This is what allows for the asynchronous nature of this application. Once those jobs are stored, there is a whole separate process that is used to actually generate and store the images for retrieval. There is a background process that runs every 30 seconds that will pull an API endpoint inside of Next to check for available jobs. All of the logic to generate images is actually stored inside of this API endpoint, which we will take a look at shortly. When the API endpoint is pinged, it will pull one available job from Postgres for processing. It will pull back one job that is in a pending status, since that is a job that needs to be processed. After that, Next will actually dispatch that message to the Stability API, where it will wait for an image to be generated, and that data will be returned as a base64 encoded image back to the API endpoint for further processing. Once the image is retrieved, it stores the image inside of the Tigris data bucket, and then finally it updates the status of the job inside of Postgres to indicate that it was a success or a failure. Because of the polling that's also performed from the Next.js components into Postgres, the image will be available inside of the user interface as soon as processing is complete. Next up, let's take a look at the API endpoint, where most of the heavy lifting for this image generation process is done. This file is stored under src app API handle job, and then in the route.ts file. So after we import all of our necessary dependencies, one of the first things that we're doing here is we're going to create an S3 client. Since Tigris is S3 compatible, we can simply use the AWS SDKs that are available in order to access and manage data within a Tigris bucket. Scrolling down here a little bit, we can see there is a single get call, which is used to execute all of the logic to retrieve an image and update the database. We're going to start here by using Drizzle in order to pull back the latest job that has a status of 0, which means it is pending. Provided a job is retrieved, we're going to go ahead and grab the job out of the response, and then we're going to set the status of that job to in progress. When the Next.js components that handles those grid items detects that a job is in an in progress status, it will update the icon to show that on the front end. Next up, we're using Fetch to access the Stability API directly. This is going to pass in the prompt as well as the height and width, as well as several other defaults. Once the image is returned, we're going to parse the JSON out of that response, and then we're going to check the artifacts field to make sure that something is pulled back for us to store inside of Tigris. Provided there is at least one artifact, which the API call will only process a single image at a time, so we can confidently know that there's only ever going to be one response inside of this artifacts. We're going to check the status to make sure it is a success. If it's not a success, we're going to throw an error and handle it later. But then we're going to pull out the base64 encoded data, which we can use to convert into a buffer, and then finally upload into the Tigris data bucket. Once the upload process is done, we go ahead and update the record inside of the database to set the status to complete, and then the Next.js grid item component will detect that change and then render the image on the front end. Before you can follow along with this tutorial, there are a number of prerequisites you will have to have installed locally or configured ahead of time. The first thing is on your computer, you'll need Node and NPM installed. This is a Next.js project, so we'll need to use NPM to install dependencies, as well as there is a helper script that will need to be run using Node. Next up, I'll be using VS Code, but you should have an IDE installed that you are comfortable working with, as well as have some familiarity with the terminal. Next, you'll need a fly.io account, since that's where this entire thing is going to be hosted. You'll also need the Fly CLI installed locally in order to build and deploy the application into your Fly account. And then finally, you'll have to have the source code repository cloned to your computer. A link to the source code on GitHub will be in the description below, so go ahead and clone that down before moving forward. The first step to getting this deployed is actually to create an API key for the Stability AI platform. You can do this by heading to platform.stability.ai and creating an account. Once you've signed in, if you head to the upper right-hand corner and click on your profile image, you'll be dropped into the API keys section of your profile where you can create an API key. Once that API key is created, go ahead and copy it to your clipboard and then save it for later use, as we're going to set the environment variables for our project in just a little bit. All right, so I'm back inside of VS Code, and we're going to walk through the necessary steps to get this application deployed into Fly. Let's start by installing all of our dependencies by running npm install, hit enter, and wait a few moments for this to finish. I have all of the dependencies already installed here, so it happened much quicker for me. However, it might take a few minutes to grab everything and pull it down. Next up, we have to change the name of the Fly app. If I head over to fly.toml and open this up, you can see there's an app name of SD Tigris Database. Now, if anyone else has stepped through this guide or tutorial and has deployed SD Tigris Database out into Fly, this thing will fail. So what we're going to do is we want to rename this into something that is unique. Now, you can come in here and you can update the name here, or there's a helper script provided named rename.mjs, which we can use to rename the file. So if I run node rename.mjs, this will generate a new name for us and update that TOML file so that we can see now it's SD Tigris Database followed by 81FA, etc., etc. Once that file is renamed, we can run fly launch. It's going to ask if we want to use the existing TOML file. We'll go ahead and type Y for yes. And then finally, it's going to ask if we want to tweak any of the settings. This deploy process will automatically detect that a Postgres database is needed, so we can just go ahead and click enter, and it will create all of the necessary infrastructure inside of Fly, with the exception of the Tigris database, which we'll create momentarily. Okay, so now that the application is deployed to Fly, there are a couple of extra steps we need to do before we can completely get up and running. Before we do that, we'll need to grab a connection string from this output. So if you scroll up a little bit through everything here, you're looking for a line that starts with database_URL. This is the environment variable that has been set in the Fly environment in order for the application to connect to the database. So copy everything here, including the database URL, and then create a new file in your project called .env.local. I have one that exists already, so I'm going to go ahead and open that and close my terminal session. I'll paste in that long connection string, and then I need to make a slight modification in order to allow our local machine to connect to the database. Now, if you notice here, the domain name for the connection string is SD Tigris Database followed by the id-db.flycast. This is an internal DNS name up in Fly, and we can't actually access this from our computer. So I'm going to go ahead and select everything from there, and I'm going to delete it and replace it with 127.0.0.1, which is the localhost address of the computer. Now, you might be wondering why we're using the localhost address when we don't have Postgres running on our computer. And the reason being is that the Fly CLI actually offers a pretty neat feature where you can proxy connections to an application that's hosted in their environment. So I'm going to open a new terminal session because the command to proxy requests is actually a blocking command, so we're going to need two of here. And then I can type in fly proxy -a, and I'm going to paste in the name of the application, followed by -db, which will be the Postgres environment that's automatically set up during the deploy process. And then finally enter the port number of 5432, which will proxy request for Postgres. I'll hit enter, and then we should see an output here that says that proxying local port 5432 to the remote of the database name. And then from here, I should be able to connect to the database using Drizzle. So I'll type in npm run db:/push, which actually runs DrizzleKit and applies the schema migrations to the Postgres database. It's going to state that there is a single table named jobs that's going to be created. I'll press the down arrow key and highlight yes and hit enter. And now the database is fully set up. I'm going to close the proxy connection and then exit out of this terminal session since we don't need it anymore. And next we need to set an environment variable for our stability API key. We can do this with fly secrets set, and then we'll type in stability API key. And then as you imagine, I'll paste in the API key that I generated earlier in this tutorial and hit enter. Fly is going to set that environment variable up inside of its environment and then restart the machines that are running the application to make sure they get the latest copy of the environment variables. Now that our stability API key environment variable is set, we can go ahead and create the Tigris bucket. We can do this with fly storage create and then hit enter. It's going to prompt us for a name for our bucket, but we can just let it generate a new one since it's automatically going to set the environment variables in Fly for us. So I'm just going to go ahead and enter. Okay, now that everything's been updated, let's go ahead and copy off this URL and head over to the browser just to see what our app looks like. Okay, this environment is entirely fresh, which is why there's no images here, but let's go ahead and type in a prompt here. I'll just say a cool tiger and submit. Okay, as we can see, the new grid item has appeared, so the job has been accepted by the API. We've moved to a spinner, which means the background job is now processing the image and forwarding it off to stability. And then finally, we have the AI-generated image that came back, as well as options to download the image or copy it to our clipboard. Storing AI-generated images is just one use case for Tigris, and there are plenty of others. To learn more about how to use Tigris in your application, go to tigrisdata.com/docs. And as mentioned earlier in the video, this entire repository is open source, so a link for that repository will be in the description below. Thanks, bye-bye.